Okay, today we're covering how to solve polynomial inequalities. Remember, inequalities are like less than or equal to, less than, greater than or equal to, and solving them also when they come in the form of rational inequalities. Here's the assignment right here. Make sure that you express your answers in interval notation. This is a page that kind of gives you step-by-step directions, so kind of if you lose track of what to do next, you can always come back to that page. All right, so here's what I'm talking about with interval notation. There are these little, which kind of look like points, sometimes they're in brackets, two numbers from left to right in the margin of that section, -3 being on the left, -1 being on the right, so it's the section between -3 and -1 on the x-axis, and then another section between 0 and 2 on the x-axis, and then finally from 4 to positive infinity on the x-axis. These are the sections that that is this answer. Again, joined by a union symbol. So let's just say all of these together. When you have this polynomial here, they didn't actually give you the polynomial, they gave you the graph. So what they're saying is f of x is the graph. Where is that greater than 0? Okay, now remember, f of x is the same as y, right? So they're basically asking you where on this graph is y greater than 0? Well, anything above the x-axis would give you a y value greater than 0. So if you have this section here, oh, but not down there, and then this section here, and then not down there, and then this section here. So kind of it comes in 3 sections. From -3 to about -1, basically, from 0 to 2, and from 4, and then this line kind of eventually goes up to positive infinity, I should say to the right, very slowly. So it turns out that this first example was indeed my answer. So that's basically what we're doing today, or at least one of the things, is we're kind of looking at what sections of the graph either are above the y-axis, greater than, or below the y-axis, less than. So in our first example, you'll notice that this doesn't have a 0 on one side. You really need that first. So the first thing I'm going to do is I'm going to move the -20 over to the left, and that gives me a better polynomial to work with. So I've got x squared minus x minus 20 is greater than 0. Now, what this basically means is, here's the polynomial, f of x, if you want to call it that. So when we basically look at the graph, where is the graph greater than above 0 for the y? The x-axis, basically. That is essentially the question that we're answering. Where is this polynomial when you graph it above the x-axis? So when is the y value greater than 0? Okay, well, we can factor this and find out. This polynomial is factorable into x minus 5, x plus 4, and let's see. Basically, this gets a little confusing right here, but here's what I'm going to do. I'm going to pretend that this says equal to 0. If it said equal to 0, I would simply set each one of these equal to 0. And then solve, which would give me x value of 5 and an x value of -4. Now these are kind of my marking points on the graph. So on the x-axis, what I'm going to draw just very basically is an x and y axis. Okay, I'm going to draw a -4 on the x-axis. Okay, that's one of my main marking points, and positive 5. Okay. So again, remember what the question is. Where is this polynomial above the x-axis? Well, this is a second-degree polynomial. When you graph that, it's going to be a parabola. Also, if you look at the x squared part, there's a positive 1 in the front. And remember when we talked about polynomials, if you had a second degree, which is an even polynomial with a positive coefficient in front, that means it goes up on one side and up on the other side, on the left and the right. So we know, number one, it's a polynomial, and we also know that it goes up on the left and the right. So just a basic sketch. I'm not being very specific about my shape or my y-intercepts here. Oh, I didn't hit that point. There we go. I basically have a polynomial that goes through these 2 points and goes up and up on the 2 ends. So to answer the question, where is this polynomial above the x-axis? It would be above the x-axis over here. and over here. So it would be basically from negative infinity to negative 4, and from 5 over to the right to positive infinity. Okay. Now sometimes things get a little bit more tricky. We're going to do one more example here. This is a third degree polynomial. I know it looks scary, but it's actually not too bad as long as you can factor things fairly well. So again, we got to have a 0 on one side of my polynomial inequality. So what I'm going to do is I'm going to subtract x and subtract 3 on both sides, which gives me this. Okay, then less than or equal to 0. And then, how do I factor this? Well, what you can do is you can factor this in parts. Any polynomial with 4 parts can sometimes be factored in parts. So I can factor out an x squared from the first 2, and factor out a negative 1 from the second 2, which gives me the same binomial. It matches x plus 3 and x plus 3, which I can then factor out, and I get that. Okay, now remember, we don't really look at this point at the fact that we're talking about a graph. We want to figure out where this graph, if this is our f of x, where is the graph less than or equal to, below or on the x-axis. Okay, so that's the question. Now what we can do is we can take this x plus 3, set it equal to 0, and we'd get a marking point at x equals negative 3. We could take x squared minus 1, factor that one more time into x plus 1 times x minus 1, and get 2 more markers, one at negative 1 and one at positive 1. So as I look at this polynomial, I've got 3 marking points on the x-axis, one at negative 3, one at negative 1, and one at positive 1. So what is this polynomial doing? Well, it's a third degree polynomial, and it has a positive coefficient in front. That's a 1. So what does that polynomial do? Basically, it starts low and then it ends high. Okay, so if the polynomial starts low, that means it's down here somewhere. So that means I go up. Now I'm going to have to come back around and hit negative 1. All of these x-intercepts only occur one time, so I know it's not going to bounce off. It's just going to cross through at each one of these points. So it's going to go up and then back at some point, hit there, turn around, come back, and then it'll end going up. So again, odd power gives you, and a positive coefficient, starts low on the left and ends high on the right. So back to the question, now that we've made our graph, where is this graph, below or on the x-axis? Well, I've got one section here that's below the x-axis and a section here that's below the x-axis. So the sections would be, oh, and this is also equal to, so I'm going to include these points right here at the end. The other graph I didn't do that. Example 1 I didn't. So I've got from this section here goes from negative infinity to negative 3. And I'm going to also add from negative 1 to positive 1. Oh, hey, I forgot a bracket, didn't I? Because I have to include that negative 3 point. Okay, same thing here. Bracket this one from negative 1 to positive 1, like so. Okay, for time's sake, I'm going to skip number 3, and I'm going to move on. I'm just going to show you the answer to number 4. It looks like this. This is all my work on number 4. Basically right there. On the bottom of the page, I simply tested some points. But it's pretty much the same type of question as the others.